All right, guys. So I'm gonna make a quick video for us to show you what it is that I'm planning on doing for our presentation tomorrow. So I'm gonna go ahead and create maybe just a 3-minute video from beginning to end, and then all you have to do is just copy my format. It's gonna be very simple. Okay? You can't fail. Just do what I do. Hello everyone, my name is Franklin Romero, and for today's plenary, I will be discussing the cardiac cell. To begin with, we need to discuss the heart in general. The basic function of the heart is to pump blood through the circulatory system. This is how you stay alive. Blood is pumped through a variety of mechanisms, but primarily you have the heart chambers and you have the arteries and veins. Yet on a more basic level, on a cellular level, you have a process which is extremely important known as the electrical syncytium. The electrical syncytium occurs through the actual cardiac cells. It is a electrical current that occurs through the tight bindings of the cells that are joined together and in unison are able to then have a beat. This is the essence of the heartbeat. Moving on, we will be discussing the cardiac muscle cell. To begin with, we must understand some basic components of the cardiac cell. Humans are born with a certain set of cardiac cells. All cardiac cells, well, the vast majority of cardiac cells are unicellular and striated. Some important components of the cardiac cell are the myofibril. These are rod-like units within the muscle cell. They are composed of different proteins, primarily actin, myosin, and titin. They are responsible for the contraction that occurs within each individual cardiac cell. These proteins that create the myofibril also help to create the shape and the size of each individual cardiac cell. Another extremely important component of the cardiac cell is the mitochondria. It is the powerhouse of the cell. It is responsible for creating ATP, and it plays a major role in the cardiac cell contraction. Another very, very important part of this link and the contraction of the heart is the sarcoplasmic reticulum. It contains calcium channels through which it can absorb and retain calcium. And it is the main component by which calcium is released and helps to create the chain link effect which is required for the contraction of the heart. Okay guys, so that's basically it. The first portion is going to be a small introduction of yourself, and then we're going to only have an introduction for about, say, 1 minute, where you introduce yourself and what it is that you're explaining. Then we will move over to a picture or a PowerPoint slide. Then we will simply have your voice and what you explain the different components that you have in the slide. Remember that you want to keep it to 3 minutes. So 1 minute introduction, 2-minute explanation of your particular muscle type. And then that's it, 3 minutes. We're going to have 3 different muscles, right? Cardiac, skeletal, and smooth. So 3, 3, 3. Let's say wrap it up in 10 minutes. That'll be done. Okay. But you only have to have roughly 1 minute of video time. The rest will just be a voiceover. All right, guys. So it's going to be very simple. Now remember, we're going to meet up at the Japanese Garden at the University of Perpetual Health System, Dalta System, at tomorrow. But first, let's meet up at 10 a.m. at the Tamayo Towers, and then we'll just walk together to the Japanese Gardens. Okay, guys, if we do this fast, it shouldn't take more than maybe an hour at best, and then that's it. We're done. Then me and a few other people will stay behind to do the video editing, and everything will be done smooth and easy, and we'll get an amazing grade. Okay? All right, guys. Manaste. I love you. Bye-bye.